All right. This is application activity for Chapter 10, t-test for independent sample t-test. Okay. And what we will do in this activity is we will examine means of two samples if they are significantly different from each other. Okay. With that being said, we need a variable that is dichotomous. That means it's two categories. Okay. And I looked our data set here. We do have some variables that are dichotomous. For example, gender. Even though we had, if you recall, we labeled gender as female, male, and other. We actually eliminated other because identification reasons. Okay, so we eventually had two categories. And then some other examples are, for example, the conditions. This one. This is one of the questions some of you were given one name and some of you were given the other name. And we provide you a question asking, provide you a description of the student. This student is this and has been involved in what activities, and asking you to rate how qualified the student will be as a president of serving as a president of the student organization or something, class president. Okay. So this condition is related to this description. Okay. I don't like how my labels go wild. Anyways, that's label. I'm just going back, and there's another one. So you received a name in either condition, either Blake, or there are two names here. These two names are given to you. And then question associated to that name is you were given a description of this student, the behavior-wise, and then you were asked to guess the student's age. Okay. So these are some of these relevant variables that I can think of. And for gender variable, since this is a dichotomous variable, you can select any interested variable that you want to examine the gender difference. Okay. For this example, I am going to use this rating for how you feel like to be red reader or something like that. Let me take a look where the descriptions are. If I feel like a red reader, this is the variable I'm interested in to examine the gender difference. Okay. All right, let's before we start, one thing that we want to make sure, and I will also tell you the reason why I selected this variable for demonstration purpose. First, you need to know the assumptions related to this independent sample t-test. There are three assumptions. One is the two samples, they are independent of each other. That means how females, they rated the being a red reader is not influenced by the males. Okay. And this is independent. And the second assumption is the two samples should be from normal distribution. That means these two samples should be close to normal distribution. And the third assumption is the two samples should have the same variance, or another way to call this is homogeneity of variances. Okay, and with that being said, I am going to briefly, and that's what you need to do usually before a test. Let's check the assumptions. Okay, now I'm going to check how female and male they rate themselves as a red reader. Okay, and what we will do here is I am going to I need to graph these two, female and male, in terms of their rating being a red reader. Okay, so I'm going to just go select. This is one of the ways that I can select only some of these cases. Okay, I'm going to just use a variable name and then if condition, and I'm going to select gender equal to 0, and I've just checked that gender equal to 0 means female. Okay, and then click OK, continue. Okay, and then what we will do next is now if you take a look at the data view, you see that all gender ones are selected. Oh, actually, ones are female. I'm sorry. I just misspoke them as male. Anyway, you can check it from the coding. So all the ones are selected at this time. Okay, zeros are excluded or any other. Only ones are selected. Okay, so what we will do is we will first graph them. And some of these simple ways that you can test the assumption of normality is to look at the distribution. So graph them, and I need to graph the institution critic. Well, actually, rater. Yeah, inst rater. That's the acronym for our being like a red reader variable. Okay, so I'm just going to graph this for a brief view of how that looked like. It takes a while. It looks fine, everything here, except that one is a little bit high. Okay, and that, let's take a look. Another one. We actually, and I'm actually going to run something called QQplot. Go analyze, descriptive, and then go QQplots. And this is also one of the ways that you can check if normality is met. And select the variable. It's ins. Where is it? And another way you can check is you can just click the initial letter, and that will okay, and then test distribution, select normal. There are all kinds of other distributions, but we are testing normality, so select normal and go click OK. And usually the graph, the distribution histogram will tell you how it is. But if it's difficult to tell, you can also use this way. This way, it's a quantile plot. That means your data compared to the theoretical perfect normal data and how that looks like. If it's normal, it should be closely aligned with this solid line here. Okay, it looks okay. Okay, and plus this data only has 7 ratings, so you would expect some sort of not as normal. Okay, and that's the data for gender coded as 1. And now we are going to select gender coded as, that's gender coded as 0. Sorry, so all zeros were selected. Yeah, ones were excluded. That's why it's crossed. And then now we are selecting 1. Ones are male. And then click OK. Okay. And now if we go take a look the data view, we see that all zeros are, these cases were excluded. Okay. So ones are selected. And let's graph the ones and see how that look like. And that will be the same variable. I'll just click OK. That's pretty high in the middle and kind of low on two ends, except that this is a little bit high, and which is similar to the other category. So we will also take a look the QQ plot. And here, and this is how you mainly take a look, and that's pretty close. Most of these, except the last one, that's a little bit off. The line. So I would just assume it's normal, or it's not too badly violated for the normality. Okay. This is important because if the assumptions are not met, then there's no need for you to test this because it won't be accurate, or it won't be a good model anyway, because assumptions are too badly violated. Okay, so now I'm going to deselect my previous selection. So I'll use all cases and OK. And I selected these cases separately just to test the normality of the two samples, female and male. Okay, and now it's okay. It's not too badly violated. And as the textbook shared, if the sample size is large enough, for example, you have thousands of sample, then you don't really need to test this hypothesis, because when sample size are very large, the two samples will be normal. This is based on the theories. Okay. I will just go analyze now. Okay. Analyze, and another assumption, if you recall, is homogeneity of variance, which means the variance of the two samples are equal, right? They are assumed to be equal, so that you can compare them. So this is already included in the test itself. Okay, I'm going to explain that. And regarding to the independence, it's from the common sense. Like, you need to analyze as a researcher if your two samples are related or not independent to each other for some reason. If they are not independent, you should not use this independent sample t-test. Okay. For example, one of these examples not independent would be if somehow, for example, you have repeated samples. You ask a group of student something, and you ask a group of student this same thing again, pre-test and post-test. These won't be independent because it's the same students who responded the test. Okay. Anyway, so these are assumptions. Let's go to compare means, and then go to independent sample t-test here, and click that. Okay. And then go right click and find the variable we are interested in. It's going to be inst rater. Select that. And now we also need to select group variable. For this grouping variable, what we need to do is we need to find gender. Okay. And here you see define groups. You need to make sure that this is defined. Okay. In my case, my group 1, I'll just put that as 0. because I have two coding, remember? 0 is female, 1 is male. So I'll make the group 2 as 1, okay? And I'll click OK. And now you see that we have our result for independent sample t-test. And now provides us the descriptive statistics. Female has 42 and male we have 17. And means for each sample, standard deviation for each sample, okay? And let's take a look at this independent sample test here. Okay, I feel like a rater, and each of the group rated from 1 to 7. Not as much to very likely, I guess. And then if you take a look at this, the two cells or columns here, it says Levene's test for equality of variances. This is also from the text. If you see, this is a test for if the variance are equal. And the assumption, the null hypothesis for this test is the variances are equal. Okay, so if you take a look, these here, this is F statistics, and this is significance. Basically, this is the p-value. So our H0 is the variances are equal. Okay, so now the significance is quite large. It's 0.5, right? Close to 0.5. So what does that mean? That means our null hypothesis cannot be rejected because it's quite a large probability for seeing this, okay, equality of variance. So we fail to reject the null hypothesis, so we accept the null hypothesis. That means our equality of variances, this assumption is met in this case, in these two samples, okay? And then what this whole thing shows you here is if this significance is not significant, that means it's equal variance is assumed, okay? If in another way, if you see this as 0.000 or a very small probability, that means you need to reject the null hypothesis. That means equal variances are not assumed. In that case, you would read the second row for the output. And in our case, since this is quite large probability, we will read the first row, equal variances assumed. Okay, so that's how you will read the data. And now we see the t value is 1.128. If you recall, t value would be equal to the difference of these two sample means divided by the standard error. Okay, and now we have degrees of freedom 57. Degrees of freedom, if you recall, equals to variance of sample 1 subtract 1 plus sample size of sample 1 subtract 1 plus sample size of the sample 2 subtract 1. So basically it's 41 plus 16, which will give us 57. Okay, and now we have another, here it says sig two-tailed. What does this one tell us? Basically, this tells us the significance of this t-test. Okay, this is associated to the t value here. And it's two-tailed because all t-tests, you can either test if it's two-tailed or one-tailed. Since our null hypothesis is for t-test is this sample, these two samples, they have the same mean. That means their feeling of like to be or like rat rater is not significantly different from each other. Since our null hypothesis is that, and then our significance, our alternative hypothesis for relating to that would be, if you write that out, it would be mu1 or mu female equal to mu male. see if I can write it on here. Seems not. Anyways, maybe I can write in another place, or you can check in the textbook. Anyways, so this significance means is related to the alternative hypothesis. Alternative hypothesis is the means are not the same. Not the same means they could be lower, could be higher. This is why it's two-tailed, okay? If you have a direction, for example, greater than something or less than something, then you would use the one-tailed t-test, okay? And in this case, it's two-tailed, okay? And it reports as two-tailed. And this p-value here is 0.26, okay? And this tells us this is a quite large probability for seeing this, our data here. That means we cannot reject the null hypothesis. Cannot reject the null hypothesis means we will need to accept the null hypothesis. The null hypothesis is the means of the two sample, female, male, in terms of their rating, feel like a red radar. It's not significantly different. That means they are about the same, equally feel like a red radar. Okay. Here's the 95 confidence interval for the t statistic. Okay. All right. So this is how you will read the output. And again, the two rows here, in terms of the result, it will be up to Levene's test for equality of variances. In our case, equal variance assumed, we read the first row, okay? In other cases, if the significance for the F statistic is very small, then you would read the second row, okay? All right, that's all for today. Thank you so much.